Okay, so this problem is a supernode problem, and even if you didn't know that, if the directions didn't tell you that, you would find out soon enough. But you start it the same way. So we're going to label the nodes. So I'll pick this to be ground. And then right here, I'm not going to give that one a variable name because I know it's 6. So I'm not going to give that one a name. And then I've got a node here. I'll call that V1. I've got a node here. I'll call that V2. And I've got a node here. I'll call that V3. And let's say my problem is to find V across this 4 ohm resistor. So Vx plus minus, and say that's what my question is. Okay, so I'll start by doing my voltage equations, so my node voltage equations. So I start at V1, and I notice right away that going off to the right, I don't have a resistor, I have a voltage source. That means that I treat this as a supernode. So what this does is it gives me one equation is going to be that V1 minus V2 equals 12. Or the plus side minus the minus side equals whatever voltage this is. It could be a negative number, it doesn't matter. It's just whatever the plus side is and minus the minus side is 12. Then I'm going to write my voltage equations for both V1 and V2 in one equation. So starting at V1, going down, oh, it made a little heart, don't know why. Going down, if I called this ground, I would have V1 minus 0 over 2, plus going up, I would have V1, and the voltage on the other side is V3, minus V3 over 1. And then I don't include the middle branch because I already have that taken care of. And then I continue on with V2. And then I would say plus, and then from V2 going down, V2 minus 6 over 5, because I know the voltage on the other side of the 5 ohm resistor is 6, plus V2 minus V3 over 3 equals 0. And then I do V3. So for V3, starting by going up, I have V3 minus V1 over 1. Then going to the left, I have V3 minus V2 over 3. And then going down, I have V3 minus 0 over 4 equals 0. So I've got 3 equations. I will multiply this middle one through by 1530. And so I get 15V1 plus 30V1 minus 30V3 plus 6V2 minus 36 plus 10V2 minus 10V3 equals 0. And I'll multiply this one through by 12. And I get 12V3 minus 12V1 plus 4V3 minus 4V2 plus 3V3 equals 0. So then I can write my top equation as V1 minus V2 equals 12. And then the second one, 15 plus 30 is 45. So 45V1. And then 6 plus 10 is 16, plus 16V2. And then minus 30 minus 10 minus 40V3 equals 36. And then the bottom one, I have minus 12V1 minus 4V2, 12 plus 4 is 16, plus 3 is 19, plus 19 V3. I don't think I have any numbers here. That equals 0. So I have 1 minus 1, 0, 12, 45, 16, minus 40, 36, minus 12, minus 4, 19, and 0. So I've got a 3 by 3, and it was 1 minus 1, 0, 12. And the second one was 45, 16, negative 40, and 36. And the last one was negative 12, negative 4, 19, and 0. Solve. So V1 is 4.65. V2 is negative 7.35 volts. Don't forget your units. And V3 is 1.39 volts. And then the problem asked me to find Vx, or the voltage across this 4 ohm resistor. Well, I said that V3 is 1.39, and that was relative to ground, which was right here. And so, and that's the same as what Vx is. So that would be my answer, would be 1.39. Yes?
The second equation would be minus 0 equal to that whole thing.
Second equation, what now?
Under V1 minus V2 equals 12. That whole thing?
Yes?
How did you use the first equation? Did you add V1 and V2 together?
No, so this is the whole idea with the supernode. So with the supernode, what I did is, since I had V1 and V2, were between them was only a voltage source, then I treat this as a supernode, and I write my equations for both of them in the same equation. This was 12. So this was V1 and this was V2. So I did V1 minus V2 equals 12. I did that first. And then I did these are my currents coming out of V1. And then I go to V2, and these are my currents. So these are my V1, my currents coming out of V1. These are my currents coming out of V2. Since I'm treating it as a supernode, I put them in the same equation.
Yeah, because I was wondering why it was negative, because I thought you were using the first equation stuff. But now it makes sense.
Why, which was negative?
I thought you were going to plug in, V1, and then you're doing minus V2, which is 12. So like make that whole equation. But
Oh, no, yeah, no. This is, I write this, and then I move on, and I'm doing something different from this. Yeah, I'm not plugging in. I mean, I could do that later to solve these, but this equation does not depend on this one at all. Other questions? All right.